Good evening, everyone. So, welcome to my YouTube channel. That is third lecture. So this is we are going to this third lecture on probability theory. In this lecture, we will study additive law of probability. So before that, we will study basic facts. So you see this. You can say result. You can say propositions as well. This is result. Let S be a sample space and A, B are subset of S. Okay. It means what? It means A and B are, it means in B are events. Okay. It means A and B are events. If A is subset of B, then probability of A is less than probability of B. So let's see its proof. Its proof is simple. How? Because let's assume that A is subset of B. If A is subset of B, then what I will have, B will be a bigger set. This is my set B. This is B set. And A is inside it. So this is A set. Okay. So I am writing A by this way. Okay. And I am writing B by this way. So how can I write B? B can be written as A union B set minus A. Okay. Now, A intersection B minus A is 5. Okay. It means A intersection B complement A. It means B set minus A is equal to 5. What does it mean? It means that A and B minus A are mutually exclusive events. Therefore, if we have mutually exclusive events, then probability is on their union is nothing but sum. It means probability of B is equal to probability A union B set minus A. That will be union because A and B complement B set minus A are mutually. So probability will be additive here. So it will be probability of A plus probability of B minus A. Okay. So what we have? We have probability of B is equal to probability of A plus probability of B minus A. But we know that, so this will be greater than equal to PA because probability is always non-negative function. So it will be non-negative. So we are adding non-negative things. So we are adding non-negative things. Okay. So we are adding non-negative things. Because A set minus B, so I should write here because probability of B minus A is non-negative. Okay, non-negative. So this sum is greater than PA. So this implies PB is greater than PA. Okay, it means I can write it in a another way. PA is less than PB. Okay. So what we have? PA is less than PB. Okay. So we have to. Okay. So remark not remark we can say let S be a sample space and A and B are subset of S. Then probability of A intersection B less than probability of A and probability of A intersection B is less than probability of B, and consequently probability of A intersection B is less than maximum of probability of A probability of B. Okay. So how we'll prove this part? Okay. Okay. You see that A intersection B is subset of A and A intersection B is also subset of B. So by proposition, we have what we have? Probability of A intersection B is less than equal to probability of A, and probability of A intersection B is less than equal to probability of B. Okay. So what we have? So we have this one. Now, next, PA and PB both are less than the maximum of PA, PB. Okay. But A intersection B probability is less than both these. What does it mean? It means that probability of A intersection B is less than maximum of PA, PB. Okay. So this is proved also. So this is proved, and these two parts also proved. Okay. So another remark I am writing. Let S be a sample space and A and B are subset of S. Okay. Then probability of A is less than probability of A union B. Okay. Probability of B less than probability of A union B. and consequently maximum of okay. So we can write here one thing previous. So I should write here A intersection B. I should write here minimum. Okay. I should write minimum here. So minimum is there. Okay. So by mistake it is written. So minimum is there. So minimum. Okay. So this is less than this. So each one is less than. Okay. So this implies this implies this implies B A intersection B is less than equal to minimum of, because each one is greater than B intersection B. So their minimum will be greater than A intersection B. Okay. So this is true. So I should write minimum here. So minimum. Okay. Minimum here. Okay. Now we are going to prove next. Let S be a sample space, and so in previous remark we have taken that A probability of A intersection B is less than equal to minimum of probability of A and probability of B. Now we are going to do another remark. Let S be a sample space and A and B are subset of S, then probability of A is less than equal to probability of A union B, and probability of B is less than equal to probability of A union B, and consequently maximum of PA PB will be less than probability of A union B. Okay, this proof is also simple. Why? Because A is subset of A union B and B is subset of A union B. Okay. So by proposition, we have probability of A is less than probability of A union B, and probability of B is less than equal to probability of A union B. So we have proved this part. Now next, because probability of A is less than probability of A union B, probability of B is less than probability. So this implies maximum of A union maximum probability of A and probability of B will be less than probability of A union B. So this part is also true. Okay. Okay. Next one, additive law of probabilities. Let S be a sample space and A, B are events. Okay. Then probability of A union B is equal to probability of A plus probability of B minus probability A intersection. So let's prove it. Okay. So here, so this is my set A. This is my A. And this is my B. And what is this set? This set is, this is A. This is set B. This is set B. Okay. And this set is A intersection. So how we can write A union B? I can take full set A, this to this, and I can take this part, this much part. So what is this much part? This much part is, I'm writing here, that is B complement A. So A union B is nothing but A union B complement minus A. Okay. But what is here? Here, A intersection B minus A is 5. It means A and B minus A are mutually exclusive. Okay. So therefore, probability of A union B is probability of A union B minus A, because both are mutually exclusive, so probability will be additive. Okay. So what we got actually? So we got probability of A union B is equal to probability of A plus probability of B minus set minus A. Let's say this equation number 1. Okay. So this is equation number 1. Okay. Next, what is B minus A? How can we write? We can write it B minus A intersection B. Both are same thing. Okay. You take B set minus A, or you take first intersection of B with A and you take its set minus phi, or you take its set minus from B. Both are equal. Okay. Okay. Now, B is equal to, now B is equal to, B is equal to, B is equal to B minus B complement A is equal to B complement A intersection B. Now, so B minus, now B is equal to B set minus A intersection B. Okay. So B set minus A is equal to A B intersection B is subset of B. So this implies B can be written as A intersection B union B minus A. Okay. So I should write here A intersection B complement B minus A is equal to phi. Okay. It means A intersection B and B set minus A are mutually exclusive. Therefore, probability of B is equal to probability of A1 B, sorry, A intersection B A intersection B union B set minus A. Okay, but both are mutually exclusive, so we have probability of A intersection B plus probability of B minus A. So this implies probability of B is equal to probability of A intersection B plus probability of B minus A. Okay, set minus. So solve this for B minus A. So what we will get? So what we will get? So here this much is required. So what should I write here directly? I should write directly here this much fact only, that A intersection B is subset of B. Okay, so this implies B is nothing but A intersection B union B minus A. And you see that these are phi. It means A intersection B and B complement A both are mutually exclusive. So therefore we have this one. So we have solve for B minus A. This is PB minus BA intersection B, PB minus A. So what we have? What is the value of this? PB minus A is equal to PB minus BA intersection B. So this is minus. That is set minus and this is minus. So let's see. So from 1 and 2, what we have? From 1 and 2. So putting the value of 2, putting a value of B minus A from 2 in 1, we get what we get? PA union B is equal to PA plus PB minus PA intersection B. So this is done. So additive law of probability is done. Now we'll do one example here based on this. Okay. So what is the probability? What is the probability what is the probability of getting a total 7 or 11 when a pair die when a pair when a pair of pair dies when a pair of pair dies is toast. So let's see its solution. So a pair of pair die. Pair means two dies are toast. So what is the sample space? So sample space is 1, 1, 1, 2, okay, 1, 3, okay, 1, 4, 1, 5, 1, 6, okay, 2, 1, okay, 2, 2, 2, okay, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So this is sample. Sample space will contain 36 elements. Okay. So these are 36 elements. So what is NS? NS is 36 elements, contains N. So number of elements in S is 36. Okay. Let A be the event of getting let A be the event of getting total 7. So what is this? So what will make 7? So which are making 7? So 1 and 6 will make 7, and 6 1 will make 7. Okay. And 2 5 will make 7, and 5 2 will make 7. Okay. Okay. And then 3 4 will make 7. 4 3 will make 7. 5 2 okay. So these are the only possibilities. So what is the probability of A? What is the probability? What is the number of elements in S? Sorry, A. Number of elements in A. Number of elements in A is 6. So what is the probability of A? Probability of A is nothing but probability of number of elements in A divided by number of elements in 6 upon 36. So this is 1 upon 6. So 1 upon 6. So probability of A is 1 upon 6. Now let B is equal to the event getting total let B be the event of getting 11. What is this set? This event 1. So it will be 5, 6, 6, 5. Okay. Only 2 possibilities are there, no other. Okay. So how many elements are there in this set? So getting total 11 here. So I should write here. Getting total 11. So these are only 2 possibilities. How many elements B has? 2. So what is the probability of B? NB upon NS. That is 2 upon 36. That is 1 upon 18. So 1 upon 18. Okay. So probability of B is, so this implies probability of B one upon 18. So what is the event? So A union B is, so what is the A union B? A union B is, what is this? This is the event of getting 7 or getting total 7 or 11. Getting. So first of all, I should take intersection. What is A intersection B? A intersection B is event of getting 7 and 11. Getting total 7 and 11. So tell me what is this? We are finding a event of getting a total 7 and 11. It is not possible. You take 2 order pair, their total is 7, then it cannot be 11. If their sum is 11, then it cannot be 7. So this event is nothing but 5. Okay. So A intersection B is, you take in both the sets A and B. What is A? What is A here? A is this set. Okay. And B is this set. So both the sets are 5. There is no common element. So A intersection B is 5. So there is no common element. So this implies A intersection B is equal to phi. So this implies the probability of phi is always 0. Okay. Because in the intersection of A and B, there is no common element, so it is phi. So probability of A intersection B is 0. Now, what is A union B? The event of getting 7 or 11. Okay. And we have to find the probability getting total 7 or 11. The event of getting total 7 or 11. And we need to calculate the probability of this event. Okay. It means we have to find probability of A union B in question. It is required. It is asked. Okay. So how we will calculate? By additive law of probability. Okay. By additive law of probability, we have PA union B is equal to PA plus PB minus PA intersection B. Okay. So what is this? PA is 1 by, what was that? 1 upon 6 it was 1 upon 18 and this is 0. Okay. So this is 0. So then what is this? This is 1 upon 6 plus 1 upon 18. To take LCM here, so this is 3 and this is 1. So 4 upon 18. So this is 2 upon 9. Okay. So probability of A union B is 2 upon 9. Okay. Therefore, the probability of getting total 7 or 11 is 2 upon 9. So this is the answer. So we are done. Okay. So in this lecture, we have discussed the additive law of probability and we have done one example on it. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you. We will see you next lecture. Thank you.